So let's start. So hello everyone, I'm Alejandro, I'm a solutions architect here at AWS, and along with my colleague Ines, we will be hosting the session on databases on AWS. So this first session will focus on relational databases. Right, so this is the table of contents. So today we'll talk about the difference about modern applications and their requirements, and why AWS's databases are purpose-built for modern application requirements. So we will go over AWS's offer on relational databases. As you can see, there's the table of contents. So as I said, first of all, we'll look about on the modern application requirements. We will have a look at how to move to fully managed databases services and why you should consider purpose-built databases. Also AWS's databases. We will look at each one of them and what the right tool is for the right job. And we will conclude with key data points for selecting the right database and how to migrate. So let's get into it. So before we can talk about how to take advantage of data, let's first talk about the three major data trends that impact the way you think about data. So the three trends, you have them on the slide there. So first one is the explosion of data. So as I'm sure you know, there is an explosion of data being generated. So now as a business, you need to track where the data comes from and the type of data there is. So the data is not only generated by your business, but it is also generated by network connected smart devices. And these smart devices produce real-time data such as mobile phones or connected cars, smart homes, and so on. So by our estimates, data grows 10 times every 5 years. So to take advantage of all of this data, you need to partner with someone who can easily harness this volume of data. So the second trend is about the microservices and how microservices change data and analytics requirements. So organizations are moving from development of monolithic applications to microservices architecture. Microservices lets organizations break down a complex problem into independent units so that developers can operate in small groups. However, there are two main implications when moving to microservices. So the first one is that developers can break down applications into smaller pieces and then pick the best tool to solve each problem. And secondly, it also increases the need for real-time monitoring and analytics to understand what's going on with the different microservices and how they're interacting with each other. Then also analytics, it's because of this that analytics also needs to be built into your application and to the specific microservices to monitor what is going on in real time. And then the third trend, it's about the rapid rate of change driven by DevOps. So as we innovate quickly and the velocity of IT changes, businesses are transforming IT to the DevOps model. So this model uses automated development to enable continuous development, deployment, and the improvement of software. So this means that when you're thinking about your data and how you're designing your data platform, what type of database you're choosing, you also need to be aware of how DevOps works, and you need to be aware of the rapid rate of change that occurs through this model. So next, so self-managing databases and analytics services is complex, time-consuming, and expensive. So for customers running legacy databases and analytics infrastructures on premises or self-managed in the cloud on EC2. So EC2 is our elastic compute offering. So it's basically virtual servers in the cloud. Provisioning, operating, scaling, and in general, managing databases is a tedious, time-consuming, and expensive task. So customers need to worry about the operational efficiency issues, such as hardware and software installation. Also, they need to worry about capacity planning and scaling clusters for compute and storage. And security and compliance issues when it comes to these databases. So once again, these are some of the problems that our customers run into when they're using self-managed databases, and we will take a look at the difference between self-managed and fully managed by AWS in the coming slides. So to get more value from their data, customers are doing these three things. They're moving to a fully managed database service. They are building modern applications with purpose-built databases, and they're breaking free from legacy databases. But for now, let's look at the first point here. So moving to fully managed database service. So since the beginning of Amazon.com, we have run some of the world's largest and busiest production relational databases. So we understand how expensive and complex it can be to manage database administrative functions. So we talked about the administrative functions in the previous slide, but they include patching cycles, performance optimization, backup and disaster recovery. And adapting these operations to the cloud also requires new skills and training. So this is why we created managed database services, so that you do not need to worry about that, and you can increase efficiency, first of all. And then secondly, by increasing the efficiency of your application, you will also be able to reduce costs. So for example, when it comes to scaling your databases, if you have spiky workloads, instead of constantly over provisioning your databases for peak capacity, you can use our services, like for example, Amazon Aurora Serverless version 2. And Amazon Aurora Serverless version 2 allows you for instant scaling in fine-grained increments. And thirdly, because you increased the efficiency and you reduced costs, you as a business, as a customer, you're also able to focus more on innovation. So you're able to you're freeing up your team resources, and you can redirect the staff that was trained on databases so that they can focus on innovating for your company. Okay, so this illustrates the difference between managing databases. So in the next slide, we'll take a look at the difference between self-managed and fully managed. But in a fully managed database, so this means that AWS takes care of the undifferentiated heavy lifting and the administrative operations. Your responsibility will be limited to designing the schema, constructing the queries, and also optimizing the queries. And AWS is responsible for the rest. So these administrative tasks, so the automatic failover, the software updates, the isolation and security, the routine maintenance. So once again, this leaves you to do the tasks that matter the most to your application. So
okay, sorry Alejandro.
yes.
Do we have any questions, please? أي أسئلة? Is there anything that is not clear? Anyone needs to translate it in Arabic? We can go on. Okay. Thank you, Alejandro. Okay, you can continue, please.
Okay.
Arabi. Okay, just second. Okay, just second. Okay. This session, okay, Dr. Fadi, this session is not about microservices, okay? احنا مش هنتكلم عن المايكرو سيرفيسز النهارده يا جماعه، في عندنا سيشنز تانية هنتكلم فيها على المايكرو سيرفيسز وعن السيرفرلس. اوكي، بس هو النهارده بيتكلم على ان استخدام المايكرو سيرفيسز ده بيأثر معانا في كميه الداتا اللي احنا محتاجينها. تمام. الملخص بتاع الجزء اللي فات كله عشان برضو الناس تبقى كلها متابعه معانا. خلاص، الفكره كلها في ايه؟ ان هو بدأ يتكلم على الداتابيزز بشكل عام، ان احنا لازم عشان في الجزء بتاعنا او في الشركه بتاعتنا او في المصنع بتاعنا عشان نبدأ نشغل الداتابيزز بتاعتنا بنحتاج ان احنا ننستول الداتابيز، محتاج ان احنا نمنتين الداتابيز، محتاجين ان احنا نمانج الداتابيز بنفسنا. فبيقول لك ان امازون دوت كوم في الاول خالص بدات تعتمد على الداتابيزز، لكن لقت ان الموضوع ده مرهق، ان هي عندها كميه كبيره جدا من الداتابيزز، فصعب ان هي تمانج كل الداتابيزز ديت. وبالتالي بقى الموضوع اسهل ان هم يشوفوا سولوشن ان يأوتوميتوا عمليه المينتننس والمانجنج بتاعه الداتابيز. فبدأ يظهر الفكر بتاع المانجد سيرفيسز في اي دبليو اس. فالنهارده احنا عندنا مانجد سيرفيس او مانجد سولوشن في اي دبليو اس للداتابيزز، ان هو بقى بيقدر ان هو Alejandro, please, would you please bring the previous slide, please?
This one?
Yes, please. اوكي. فكل الحاجات اللي على اليمين دي يا جماعه بقت اي دبليو اس ريسبونسبيلتي. يبقى انا النهارده لما هروح لاي دبليو اس، زي ما بدانا نتكلم من المره اللي فاتت مع بعض، اي دبليو اس او الكلاود مش مجرد ان انا بديك فيرتشوال ماشينز وبس، لا ده انا بديك سيرفيسز. فمثلا الجزء بتاع الداتابيز، الجزء اللي على اليمين ده كله، ان انا افرض الداتابيز بتاعتي وقعت لاي سبب من الاسباب، اي دبليو اس هتبقى مسؤوله ان هي تعمل فيل اوفر. اي دبليو اس هتبقى مسؤوله انها تاخد لك باك اب وريكفري. هي المسؤوله انها تعمل ابديتس وبترن الباتشز بتاعه الداتابيز بتاعتك. فلو في اي باتش جديد نزل للداتابيز بتاعتك، اي دبليو اس مسؤوله ان هي تعمله. فكل دي حاجات بتعملها لك اي دبليو اس. دي بنسميها ايه يا جماعه؟ بنسميها undifferentiated heavy lifting tasks. undifferentiated heavy lifting. يعني ايه undifferentiated heavy lifting؟ يعني دي تاسكات اي حد في الدنيا عنده داتابيز بيعمل التاسكات ديت. وبالتالي هي ما بتفرقش ما بين شركه وشركه، ما بتفرقش انت كويس ولا وحش. هي في الاخر انت هتعمل انستول للداتابيز زي ما انا هعمل انستول للداتابيز. انا هعمل باك اب وريكفري، انت هتعمل باك اب وريكفري. فدي undifferentiated tasks. دي ما بتفرقش بيننا وبين بعض، ما بتفرقش ده كويس ولا ده وحش. ما بنقولش ان الشركه دي كويسه عشان بتعمل انستوليشن كويس للداتابيز. في نفس الوقت هي هيفي ليفتنج بالنسبه للشركات، ان انا اقعد افكر في ان انا اخد باك ابس، وان انا لما الداتابيز بتاعتي تقع اروح اشغل انستنس تانية والكلام ده. الكلام ده بيعمل وجع دماغ زي ما بنقول كده بالعربي للشركات. انا عايز اركز في البيزنس بتاعي. انا راجل ببيع بضاعة، او انا راجل مثلا شغال في المقاولات او كده، انا عايز اركز في البيزنس بتاعي. انا مالي انا ومال الداتابيز اللي بتقع في الشركة. فاي دبليو اس بتقول لك ان الاندفرنشيتد هيفي ليفتنج دي احنا اللي بنعملها عندنا في اي دبليو اس. اوكي. ولو في اي اسئله برضو يا جماعه، حد عايز يسال ممكن تساله في الشات برضو، ما فيش مشكله. اوكي. ثانك يو الجاندرو. would you please continue please? thank you.
Yes. Okay. So basically, this is the difference between having a fully managed database either either in the cloud or on premises or some sort of somewhere else. When you are self-managing the database, so if this is in AWS, you can, for instance, you can have your database running on top of EC2, top of a virtual server. So this means that you would be responsible for everything in the database. It means you're responsible for designing the schema, for constructing the queries. You're responsible for setting up the automatic failover and so on. And the difference between that and using a fully managed AWS service, like for example RDS for relational databases, where you're only responsible for the first three things, right? So you're only responsible for designing the schema, query construction and optimization, and AWS and the rest. So these are the administrative tasks. Okay, so now moving on. So when you're moving to fully managed databases, you need to migrate on-premises or self-managed databases, as we've explained in the previous slide, to fully managed services. So the most straightforward and simple solution for many customers who are struggling to maintain their own relational databases at scale is a move to a managed database service, like for example, Amazon RDS or Aurora. So these are two relational database fully managed services. And in most cases, these customers can migrate workloads or applications to a managed service without needing to re-architect the application. So this is very important because once again, you do not waste any effort in re-architecting your solution. So in general, whether you're migrating to relational fully managed database services or non-relational fully managed database services, the target customer the target customer is someone that is self-managing databases on premises. So either on premises or in EC2 or in another public cloud, someone who would like to reduce the database administrative burden and reallocate their resources to app-centric work. It's someone that does not want to re-architect the application and wants to continue leveraging the same skill sets. And it's someone that needs a simple path to a managed service in the cloud for database workloads. It's also someone that wants better performance, availability, scalability, and security. So in the diagram there, you see that there are different ways that you can migrate from relational databases. So be it Oracle, MySQL, MariaDB. In AWS, the two services we have are Amazon Aurora or RDS for relational databases. And in the case of non-relational databases, like example, MongoDB or Memcached, you could migrate to any number of offerings like Amazon Document DB or Elasticache or Amazon Keyspaces. So in conclusion, to summarize all this, the move to managed relational databases, you're migrating an on-premise or cloud-hosted relational databases to managed services. It helps you to reduce the database administrative burden. There is no need to re-architect your existing applications, and you will get better performance, availability, scalability, and security. And then depending on the technology you use, you could choose either Amazon Aurora or Amazon RDS. So now the second point, to get more value from their data, customers are also building modern applications with purpose-built databases.
Sorry, Alejandro, please.
Yes.
Do we have any questions, please? Any questions? Do we need to repeat it in Arabic again? Okay.
All
Okay,
right.
thank you. Okay, thank you. Thank you, Alejandro. Thank you.
Perfect. So now to understand this a bit more, I would like to talk about the app architectures and how the patterns have evolved over time. So the first thing that we have here in the 60s and 70s, we have mainframes, which was the predominant way of building applications, right? So everything was put into the mainframe. Secondly, in the 80s, we have the client server architecture. So this changed significantly the way the applications were built because they started becoming a bit more distributed. However, the underlying data model was also predominantly structured. And then the internet arrived in the 90s, and the three-tier architecture was born, and as a result, this architecture was born. Now, today, fast forward to today, and we have microservices architectures, and this is how applications are usually built. This is one of the ways that applications are built in the cloud. So microservices have finally reached the databases. So this means that developers can do what they do best, which is breaking large applications into smaller services and picking the right tool for the right job. And this avoids a single overburdened database with one storage engine and one compute engine trying to handle every single access pattern. With microservices, we have more flexibility. So now the expectation also for today's applications is a bit different from what it used to be. The latency requirements are much lower, so we need much faster applications. And applications and databases are also expected to handle millions of transactions per second, with many millions of people using the applications simultaneously. So these expectations have resulted in data management systems with specialized storage and compute layers. Yes, with specialized storage and compute layers that are optimized for given use cases and workloads. So these are some of the modern application requirements. So first of all, in terms of users, so user growth, this is a common key performance indicator for businesses, and the cloud's global reach enables the businesses to touch millions of new customers. Secondly, data volume. So businesses are capturing more data about their customers to increase the value of their existing products. So this means that now we deal with terabytes and in some cases petabytes of data. Locality, of course, with the cloud, businesses and customers, they want to scale so that they have a global presence. In terms of performance, we talked about this in the previous slide. So the applications have a requirement of microsecond latency. They need to handle millions of requests per second. The access pattern in this case is not limited to mobile phones or laptops. We also need to take into account the Internet of Things and other devices that can access that can access our applications and in our case our databases, and they need to be able to scale virtually in an unlimited manner. Okay, so now instead of building a monolithic application, we can build microservices with purpose-built tools so that developers can break down complex applications into smaller pieces, and they can pick the best tool to solve each problem. So now developers, thanks to microservices architecture, they're able to break down complex applications into smaller pieces and solve each problem with specific and purposefully built tool. This also ensures that the applications are well architected and they can scale effectively. So in the past, of course, if you had a mainframe, you had to scale the whole architecture. Now with microservices, depending on the service that is queried the most, you can just scale that independently. Developers are now building highly distributed applications using a multitude of purpose-built databases. Okay, so now this is a list of different databases that are available. So we have relational databases, which is what we will talk about today. We also have key value databases, document databases, and so on. So this just gives you an idea of all the different technologies that are available. And then in the second row there, what you can see is some of AWS's offerings. So for example, for relational databases, we have Amazon Aurora or Amazon RDS. For key value databases, a very common database that you might be familiar with is Amazon DynamoDB.
Alejandro,
Yes.
if you don't mind, we will take a pause here.
Okay.
Of 15 minutes, if everyone agrees. And so we would come back at 45. So for you, most of you probably 5:45, if that's okay.
Yes thank you إنسيات. اوكي يا جماعة، ناخد بريك ربع ساعة خلاص لغاية 6 إلا ربع إن شاء الله عشان وقت الصلاة بإذن الله. اوكي ثانك يو.
Hello, everyone. I'm not sure if you're back yet. Maybe let's wait one more minute. Okay. Okay, Ines, Ahmed, if you're all right, I think we can continue, right?
Yes, please. Yes, please. We can continue now, Eljo.
Okay.
Okay.
So this is where we left off. So thirdly, to get more value from their data, customers are also breaking free from legacy databases. So let's take a look at this. So many existing applications are built on legacy databases, and customers have had to deal with old guard database providers that are expensive, proprietary, so they have high lock-in, they have punitive licensing, um, and they perform frequent audits. So customers are looking to break free from that. So because of this, customers are trying to move as fast as they can to open source databases like MySQL, PostgreSQL, or MariaDB. However, the problem here is that getting the same performance on open source databases as you get on commercial grade databases is difficult. So we have done this at Amazon.com, but it has required a lot of fine tuning. So customers that are moving to open source databases have asked us for the performance of commercial grade databases with the pricing, freedom, and also the flexibility of open source databases. So in general, our approach to databases, so the value proposition from AWS for databases, first of all, it gives you tools to help you innovate faster through managed services. AWS offers a portfolio of purpose-built services that is specifically optimized for your workloads. And thirdly, AWS provides services that help you migrate existing apps and databases to the cloud. So here, this is a diagram showing the different kinds of database technologies available. So today we will look at the first one, which is the relational databases. Okay, and now moving on to NoSQL versus SQL for a new application. So for NoSQL, one of the options we have available is Amazon DynamoDB. And for relational databases or SQL databases, we have Amazon RDS. So SQL databases are used when you need joins, transactions, and frequent table scans. And your team already has SQL skills. So that's it from my side for the presentation. Now I will let my colleague Ines continue.
Thank you, Alejandro. Can you hear me all right?
Yeah, yes,
Yeah.
yes, yes,
Thank you.
Ines. Yes. Excuse me, Ines, please. Do we have any questions till this point, please? Any translation is needed in Arabic? Any questions before we go through? Dr. Fadi, I see some raised hands. Is there a question or it is by mistake? Okay. So any questions, please? Any clarification in Arabic needed, please? أي ترجمة بالعربي، أي حاجة بالعربي يا جماعة، ولا كله تمام؟ Okay, thank you. Okay, Ines, hold on, please. Go on, please. Thank you.
Thank you. Hopefully, you keep seeing my screen now. Yes.
Sorry?
Do you
Yeah,
see my screen?
yes, Dinesh, we can see your
Yeah.
screen.
Thank
Yes,
you.
yes, you
Thank you
can
all.
see, yes, yes. You can see your screen, yes.
Okay. Well, we just had Alejandro presenting us the view of databases in general, but also on AWS. And as you mentioned before, today we're focusing on relational databases. Tomorrow we'll have a session on no non-relational databases, so that's use unstructured data. And let's now get into the offer of AWS for these relational databases. And what we have is Amazon Relational Database Service, Amazon RDS, and we'll go have a small deep dive into what it is and what we can do with it. So the Amazon Relational Database Service, or also called Amazon RDS, is our collection of managed services, and it makes you makes it simple for you to set up, operate, and scale databases in the cloud. It is a managed database service, so it helps you remove the inefficiency and time-consuming database administration tasks that Alejandro has mentioned before. So it means that you no longer need to provision infrastructure or maintain software as you would do in an on-prem environment. With the result of this innovation, RDS will offer you the ability to customize your managed workload for the high availability and durability that you need, which is usually one of the reasons to move to the clouds. We have features like Amazon RDS Multiple AZ. So if you are familiar with the AWS infrastructure, it would mean that you would deploy in more than one availability zone. And this would be a bit different than deploying in an on-prem environment where we usually deploy in the same physical location. This service also provides you the freedom to choose how to deploy and scale a relational database, which is also different from the traditional way. So let's look at some deployment options for Amazon RDS. So Amazon RDS allows customers to deploy relational database systems with the engine of your choice. So it means that when you move to a managed database like this, you can begin taking the advantage of the performance, availability, scalability, and security that we mentioned. And you have the choice to deploy 7 managed database engines, such as Amazon Aurora, which is compatible with MySQL and Postgres. You have Amazon RDS, which is compatible also with MySQL, Postgres, but also MariaDB, Oracle, and SQL Server. There's also the possibility to run RDS on Outposts, and we will get into that in a bit. And also the possibility to have RDS custom. So let's look into RDS for the open source engines that we mentioned before. So RDS offers 3 fully managed open source database offerings. So as mentioned before, Postgres, MySQL, and MariaDB. This is an engine to provide you the same benefits as these open source databases, but it also simplifies the database management tasks that we had before. So it enables you to quickly start building your applications and even migrating existing ones. We will also get into migration slightly a bit after. So with these open source engines, customers can deploy the familiar code and features and tools and extensions that they were already familiar with. Furthermore, it will also keep you with the latest engine major and minor versions to ensure that you have the latest software innovations and benefits, which means that instead of you having to keep upgrading the version or the engine to the latest version. By using RDS, you'll have this done by default. You are so breaking free from the management tasks that you can be used to if you're managing databases. I don't know if any of you here is familiar with this task. Also, we have also been able to reduce the complexity of migration, which we will get into in just a second. Let's look now into our commercial engines. So the two fully commercial engines that we have is RDS for Oracle and RDS for SQL Server. Same thing applies here, where you would have the same code and features that you are used to, but we can develop and roll out our new applications, always trusting that we will have the latest the system version happening. Amazon RDS also offers licensing and deployment flexibility, so you can choose deployment options with license included, or even bring your own licensing model. So in this way, you could bring, if you already have licenses for search databases and you are considering a migration, it would be possible for you to bring these licenses. There are no upfront fees or long-term commitments, which means that you can choose to pay hourly in the pay-as-you-go model, which I'm sure you probably are familiar by now, but in AWS, almost everything is with pay-as-you-go pricing, which means that you do not have to pay upfront, like usually when you deploy such configurations on an on-prem environment. I don't know if there are any questions until now, just taking a brief pause here.
أي أسئلة يا جماعة? Is there any questions? Oh yes, we have a question in the chat. Please, Inash.
Yes, I'm trying to see the chat as I'm sharing it a bit.
So the question is, when the role of AWS are come in which stage of database? So I'm not sure I understand the question.
Yeah, if you could please clarify, and we will get into it.
دكتورة أسماء لو سمحتي نستأذنك بس توضحي لنا السؤال شوية. Okay, so Dr. Asma is asking about what is the role of AWS after creating the database?
Oh, the role of AWS. So when we create AWS a database in AWS, so the advantage here, which comes a bit with the role, is that it will manage the database for you. So basically things such as updates, as I mentioned before, complexity of licensing that we are seeing here in these examples, will be managed by you. So instead of if you deploy a database in a server, you have to keep updating it to make sure that it's still compliant. And then you probably can have integration issues if, for example, you're using a server and it no longer is updated with your database. This is something you would have to take care of in these management tasks. But I will have a slide here also to explain the advantages, and also what it's all about responsibility and managing what you have to manage or not. And I have a slide here to explain better what will be the role of AWS and the user. So when you move to a managed database like this, and I will go just in 2 minutes if it's okay. And I think there's a raised hand.
Yeah. Okay, Dr. Asma, would you please remember your question till the end of the presentation, because we are going to begin to discuss some of the benefits of the RDS while it's running and up and running. So this may answer your question at the end. Okay, thank you. Okay, عندنا أسئلة تانية يا جماعة؟ أي حد is there any raised hands? Any questions? Okay.
Okay.
Okay. So please go on, please, Ines.
No, thank you for your questions, and I'm going to try to clarify everything as we go now.
Okay.
So with RDS commercial engines, you have high availability. So if you use the multi-AZ deployment, you can run your mission critical workloads with high availability because it has built-in automated failover for your primary database, which should synchronously be replicated to a secondary database in case of failure. So what I'm saying here is that when you're deploying databases in AWS, imagine you want to deploy in a region, you choose your region, and then you choose, okay, I'm going to deploy in this availability zone. RDS has this multi-AZ deployment option, which will create a standby database in another availability zone. So here we are having, so availability zones will be separated physically. So what happens is, if something happens to the availability zone where your database is, because it is being synchronously replicated to the other availability zone. This, if you select multi-AZ deployment option, what happens, it will have automatic failover. So something happens in availability zone A, because I've selected multi-AZ deployment option, I will have my database ready in availability zone B, which still stands and has, because of synchronous replication, we'll have the latest changes. And this is how we can have the high availability and how we handle disaster recovery using here RDS, which also helps us see the advantages of using AWS. Of course, you can configure similar procedures like this on an on-prem environment, but it's the ease of clicking a couple of buttons and having all of this set up for us, which is the offer of AWS. Now, there is maybe a name of a database that you might not know yet, or because we were seeing the deployment options for RDS, and I'm not sure if you're all familiar with Amazon Aurora, but hopefully yes. So Amazon Aurora is a relational database service. This is a service that will combine the speed and availability of the commercial databases that we have looked for before, but it also has the simplicity and cost effectiveness of an open source database. Aurora is fully compatible with MySQL and Postgres. Sorry, I don't know if you see an annotation request on my screen or not.
At least I cannot see anything, Nish.
Okay, thank you. Thank you. I was able to decline it, but thank you, Alejandro.
No worries.
So as I was saying, it is compatible with MySQL and Postgres, but as you can see there, there are a few advantages. So that we will also get a bit into more today, as I have prepared a couple more slides on Aurora. But I just want you to, what I want to get for here is that Aurora is also a fully managed service. It will automate time-consuming administration tasks like hardware provisioning. It is highly secure and reliable. Also, it is fully managed, but I will go into more on this. So a couple of things that I wanted to mention, which are not directly relational databases, but it comes with, and when we get into the small demo that I have prepared, what happens is that these will be suggestions, and I want you to know what they mean when we get there. So Amazon RDS proxy here is a database proxy for RDS, and it will make your applications more scalable, more resilient to database failures, and also more secure. What happens is that your many applications today, when they have serverless architectures, when they're built like this, they can have a large number of open connections to the database server. And we keep opening and closing database connections at a high rate for all those connections that we have opening. And we are exhausting basically database memory and also our compute resources. with RDS proxy, what we have here is allowing to have an application pool. So the applications will share a pool, and here they'll find the connections established to the database, and they're all sharing these connections. So what will happen with what will be the benefits of this is that we'll get failover times for Aurora and RDS will be reduced to 66%. And also the database credentials, authentication, the access will also be able to be managed through the integration with other services in AWS, such as Secrets Manager and Identity and Access Management. These are services that we use to manage the security information that we need to use, and also how we access AWS. So this is one of the integrations that when we are deploying an RDS database, they will suggest to us, like, do you need an RDS proxy? If you are building such an architecture, it might be beneficial for you in terms of performance to choose such option. The other thing that I wanted to mention to you is something we will cover tomorrow, but when we have an RDS database, and we notice that we need to accelerate our application performance and also sometimes reduce costs, we can use Elastic Cache. And when we use it together with RDS, we are providing an in-memory cache with the reliability of actually a relational database. So we can attach we can create and attach an Elastic Cache cluster at the same time when we are creating it. Like this, we would be, so if you were wondering how would you handle your cache now here when using AWS, this will be an option, but will be better covered tomorrow. So regarding the questions that we got asked before, so what are we getting from RDS? What is the role after we deploy the database? So here,
Excuse me, Ines.
yes, of
Is
course.
there any question about the RDS proxy or Elastic Cache؟ في أي أسئلة عن ال RDS proxy أو ال Elastic Cache مش واضحة يا جماعة، أو الدنيا مش واضحة بالنسبة لكم؟ هو إن شاء الله بكرة ال Elastic Cache الناس إن شاء الله will discuss Elastic Cache tomorrow, but is the concept is familiar with you for RDS proxy and Elastic Cache؟ حاضر. طيب بالنسبه للار دي اس بروكسي يا جماعه، خلاص خلينا دايما نتفق على حاجه الاول، ان اي كونكشنز كتيره على الداتابيز ده بيرهق الداتابيز بتاعتنا، بيكونسيوم الميموري وبيكونسيوم الكمبيوتيشنال باور بتاعت الداتابيز بتاعتنا. وتعالوا بقى نرجع تاني للكلام اللي احنا كنا بنقوله في الاول، احنا عندنا مايكرو سيرفيسز. مايكرو سيرفيسز دي بتبقى عباره عن الابلكيشن بتاعتنا، بدل ما هي حاجه كبيره بتبقى الابلكيشن بتاعتنا عباره عن اجزاء صغيره. تخيل بقى الاجزاء الصغيره دي كلها بتفتح كونكشنز على الداتابيز، او السيرفرلس زي ما هنتكلم قدام برضو شويه، ان انا بيكون الابلكيشن عندي متجزأه لاجزاء صغيره وكلهم بيفتحوا كونكشن على الداتابيز. تخيل بقى ان في المودرن اركتكتشر دوت اللي هو باستخدام المايكرو سيرفيس او باستخدام السيرفرلس، بيكون في كونكشنز كتير جدا بتتفتح على الداتابيز. لما كونكشنز كتيره تتفتح على الداتابيز زي ما اتفقنا، ده هيوقع الداتابيز بتاعتنا، ده هيستهلك ميموري وكمبيوتيشنال باور من الداتابيز كبيره جدا. الار دي اس بروكسي بقى بيعمل ايه؟ الار دي اس بروكسي ده بيعمل بول بين الكونكشنز. يعني ايه بول من الكونكشنز؟ يعني بنيجي احنا نعمل له كونفيجريشن يفتح مثلا 30 40 50 كونكشن جاهزين على الداتابيز. طيب هتيجي الابلكيشن تطلب كونكشن، هو يديك كونكشن من عنده وما بيزودش عدد الكونكشنز، هو بيبدا خلاص ال 50 او ال 100 اللي عنده دول بيبدا يوزعهم على الابلكيشن علشان ما يفتحش دايما كونكشنز جديده على الداتابيز. خلاص انا معايا 50 او 100 او ايا كان الرقم اللي احنا عاملين له كونفيجريشن، بيبدا يوزعهم على الابلكيشن سواء بقى مايكرو سيرفيس سواء سيرفرلس. فده بيقلل الكونكشنز اللي على الداتابيز، وبالتالي بيحمي الداتابيز بتاعتي من انها تقع. فدي بيكون ميزه من مميزات الار دي اس بروكسي. بالنسبه للالاستيك كاش، الالاستيك كاش انه بيقلل الكويريز اللي بتتم على الداتابيز بتاعتك. فمثلا لو انا النهارده سي مثلا، تخيلوا كده انا عندي في الابلكيشن بتاعتي عندي لستة بتجيب البلاد. خلاص انا بقول للراجل اختار البلد اللي انت فيها، فعنده لستة بيختار منها البلد. تخيل بقى ان النهارده هيزور الابلكيشن بتاعتي 1000 واحد. ال1000 واحد هروح اعمل نفس الكويري، او هروح اجيب نفس الداتا من الداتابيز اللي بيجيبها كل واحد. يعني هعمل 1000 ريكوست على الداتابيز ما لهمش لازمه. ليه؟ لان كلهم بيجيبوا نفس الداتا. هي لستة البلاد دي بتتغير كل فين وفين، ممكن تتغير كل سنتين ثلاثة مرة، صح؟ وبالتالي لو انا عندي 1000 يوزر داخل، هيبقى عندي 1000 ريكوست على الداتابيز ما لهمش لازمة. هنا بقى بيجي دور الالاستيك كاش. انا هعمل الكويري على الداتابيز مرة واحدة بس، هجيب لستة الدول دي احطها في الالاستيك كاش. لما يجي يوزر تاني يطلبها ما بروحش اجيبها من الداتابيز بقى، لا بروح اجيبها من الالاستيك كاش. فبالتالي بتقلل عدد الكويريز اللي بتروح للايه، للداتابيز. فالار دي اس بروكسي والالاستيك كاش، على الرغم ان هما الاثنين مش حاجتين مخصوصين بالداتابيز، لكن بيساعدوا الداتابيز بتاعتي. الار دي اس بتحمي، او الار دي اس بروكسي بتحمي الداتابيز بتاعتي من الكونكشنز الكتير. في نفس الوقت الالاستيك كاش بتقلل عمليه الكويريز بتاعتي على الداتابيز. اتمنى كده تكون واضحه. نفس فكره الكاشنج عامه بالظبط. تمام، هايل. تمام، شكرا. شكرا. Thank you, Ines. You can continue, please.
Thank you, Amit.
Thank you.
So what we were seeing now is the difference of deploying a database in AWS versus deploying it on premises. And we're also going to see the differences between deploying it on an EC2. An EC2 is our compute option for AWS. So it is when you need some compute power, this would be your most flexible, configurable option. So you can choose to it would be like your virtual computer, and you can choose to deploy your database in this virtual computer. But we're going to see the differences. So when we manage a database on premises, we have everything from app optimization, scaling, high availability, database backups, patches, installs, operating system patches, installation. So here we also have to manage the server patches as well as the database patches. Then we have the server maintenance, the racks and stacks, the power, maintain the power, the internet, and the security of our on-premises, all of this. So this is what you manage all in white. So when we look into, let's move into AWS, and our first option that first come up was installing our database in EC2. And this might be still an important option if you want to manage some of these things, to have some more configurability of your deployment. So what does AWS manage here? It will manage everything from power, how the racks are placed, and stacks, where the servers will be running, all the server managing, and the OS installation. But when it comes to patching your OS, it will be your responsibility. When you install your database is your responsibility, as well as patches, backups, high availability, scaling, and app optimization. It's already a bit easier as you can choose to deploy in multiple regions to have the high availability. You can use optimizations such as auto scaling, so you can optimize the scaling part, but there's still here database software patches and installs, which you still have to manage. When it comes to a service like RDS, what we have here is, besides having everything that I said managed before, is what I mentioned. So the real value proposition, which will be to have the software installs and patches done by you, high availability will be done by you, and also the scaling. All you have to take care of is app optimization, so how to optimize your application to use the database of your choice. So I hope this answers a bit what is the role of AWS when you launch your database, which the role of AWS will be to manage all of the squares in rectangles in orange for you.
اوكي. دكتور اسماء، كده واضحه الاجابه على ايه دور AWS. What is the role of AWS after creating the database؟ كده واضحه. سؤال حضرتك تجاوب. تمام، هايل. Thank you. Thank you. Okay. It's okay. Thank you. You can move on, Ines. Thank you.
Thank you. So I just wanted to give a bit of a higher explanation on Aurora, because I skipped a bit through it a bit faster before. So Aurora, besides being compatible with MySQL and Postgres, it is actually considered up to 5 times faster than the MySQL database and 3 times faster than the standard Postgres database. It will provide you with security, availability, and reliability, but with 1/10 of the cost. So here are the real advantages of Aurora, besides being more efficient, and then comparing to those two database types that it is compatible with, it will also be cheaper than these offerings. It is fully managed by RDS, so you can launch these type of databases using the service that we were seeing before. It is a self-healing storage system. It can scale up to 64 terabytes per database instance. It will deliver high performance and availability with up to 15 low latency read replicas. So these read replicas will help you scale, if you choose to have them, will help you scale your read workloads. So if you have high intensive read workloads, you can have your writer instance, but then have up to 15 read replicas where your workloads can be reading from to optimize the performance. You also have point-in-time recovery and continuous backups to Amazon S3, which is our object service, where you can store a replica or a snapshot, let's say, of these databases, so you can restore it to make sure that you do not lose any of your data. Also, the replication comes across 3 AZs, which is also something standard in this type of services, but just so you know that your high availability will be covered. As we saw before, we would get everything that we get from RDS. We get even more with Aurora. So with Aurora, the auto-scaling happens in 10 gigabytes of increments, so you don't have to worry about pre-provisioning storage. In addition to saving you time and effort, it also avoids downtime for scaling storage, which can be very significant with databases such as MySQL. We do continuous backups to S3, and all you have to do is specify how far back you want these backups to go. We also can create snapshots instantaneously, and it won't affect any of the performance, so how it is working and running at the moment. You can also store these snapshots indefinitely. And finally, our storage layer will automatically handle things like hardware failure, which is one of the advantages. So you wouldn't need to worry about that. I wanted to check here if you want to take a small break. We had scheduled a break for I believe 15, so I'm over 5 minutes. I don't know if you would like to take a break or continue until I finish the part of the presentation.
تحبوا تاخدوا بريك يا جماعة؟ ناخد بريك 10 دقايق أو ربع ساعة. They want to continue, Ines.
Okay. Yes, so I'll finish the presentation and then we'll take a quick break before the demo, if that's okay.
Okay, great.
So I didn't want to go too deep into the features today, but let's just see here Aurora's global database structure. So it consists of one primary AWS region, where your data is mastered. So this is something that you can choose. And you can have one read-only secondary AWS region. So in this case, if you have a workload that actually would need to be replicated to a separate region, if you want to have some disaster recovery possibilities, if you are concerned that a region could fail, although this is highly unlikely, there is this option where Aurora would replicate the data to the secondary region. With a typical latency would be such as under a second, and you would still issue your write operations directly to the primary database instance in your primary region, so your default region. But when you use these Aurora global databases, you would replicate it to some other regions if you like. Another feature that I wanted to mention is Aurora Serverless. So it is a configuration for Aurora on demand and auto scaling. So it automatically starts up and shuts down, and also scales capacity up and down based on your application's needs. You can run your database in the cloud without managing any of the database instances. And you can also use Aurora Serverless V2 instances along with provisioned instances in your existing or new database clusters. So instead of choosing, when you're deploying your Aurora database, you can select that you want it to be serverless, so it starts and shuts down automatically and also scales based on the application needs. And imagine you already have an instance which is not running on the serverless mode. It is okay, you can have different instances in the same database clusters. So to finish up on RDS and Aurora, so what is the role of RDS in Aurora as part of the total portfolio of AWS purpose-built databases? So if you have a commercial component, you require investment to be modernized, you can add, for example, RDS commercial instances. If you have a specific database requirements, like Oracle Suite, you could have RDS custom for privileged access. If you prefer to have a relational database, but you have heavy reads, for example, you can add Elastic Cache to boost the speed. So these are some of the options that you have. But there will be other use cases where these might not fit. And that's why we have our session tomorrow on non-relational databases for your unstructured data, and where we will cover different options. To start finishing, the last topics that I wanted to talk to you about is some ideas on how to choose the right databases for your application. So this might be, when looking at such a broad portfolio, this might be something that comes up to your mind. So let's go over some key principles for choosing the right database. So when we imagine, the first thing that we need to take into consideration is that when we imagine the ideal database, it would allow us to store all types of data. It will provide the storage always with strong consistency, and it would be scalable and high performance. Also, in the perfect world, it would have no downtime and also be cost effective. The thing is that this ideal database that would fit our use case perfectly, and every use case that we come up with does not exist, and it's a myth. So in reality, what we have to choose the right database for the right workload. And what does it mean? We need to be able to scale. So now that we're choosing the right database, we'll need to analyze the type of data we want to store, our access patterns, and let's put these tips into something more concrete. When we are choosing a database, we can define a 360 view of our workload, and there are a couple of questions we can ask ourselves. So let's start with our business objectives. So what do we need this database for? Then we can move into the functional requirements. So what functionalities do we need to provide? Does it integrate with my workload? Do we need some external integrations? Will this database fit such integrations right now? And will some integrations be needed in the future? Then we look into resiliency and the resiliency that we need or want. So will it fit my current resilience needs? What about future needs? In this case, for example, we can look when choosing AWS, will deploying in a multi-AZ setting fill my resilience needs? Deploying in multi-region maybe would be necessary. So these are things that we need to take into consideration. Then let's look into performance needs. Is the database performant? Do I need to choose, for example, Aurora over RDS MySQL because it can be more performant? Or is this not something that I need to be concerned about? Also, we should check if it will keep being performant as my workload increases, because as we add more data or have more users querying it, will it still be performant? And here we could consider things as we saw today, RDS proxies, caches, to optimize this. Also, we need to look at our operational needs. Can I manage this database the way that I'm expecting? Will it operate efficiently? And at last but not least, always number one priority, does it fit my security and compliance requirements? So what security does this database offer? And is it compliant with what I desire? So these would be some questions to give you an idea when choosing a database. We can also check the database solution affinity. So we can check if it is widely adopted in the market or not, which would mean that it has been tried and tested, and there's a lot of expertise available in the market that work with this. So usually when we are deploying something new, it hasn't been as tested, there won't be so much documentation on it. So this could be also something that we look into it, if it is widely adopted. And this will affect how many people are still contributing to developing it and upgrading the database, and also what integrations with other solutions might come up in the future. So this could be something to look for. So the solution affinity, how broadly adopted it is, and see if it's a good fit for our use case in the future.
Okay, Ines, would you please return back to the previous slide, please?
Of course.
The previous one.
Yes, this one.
yes please. اوكي اوكي سارة، دلوقتي لما احنا هنيجي نختار الداتابيز بتاعتنا، في حاجات كتير لازم نبص لها مع بعض. اول حاجه البيزنس بتاعي عايز ايه، الفانكشنز بتاعتها عامله ايه، الانتجريشن مع الابلكيشنز التانية او مع ممكن تكون مع داتابيزز تانية، الريزيلينس في الابلكيشن. يعني ايه ريزيلينس؟ يعني انا النهارده لو الداتابيز بتاعتي وقعت هيحصل ايه؟ تمام. هل هيبقى مثلا عايز يكون عندي داتابيز تانية بحيث لو واحده وقعت التانية تشتغل لوحدها؟ طيب هل التانية او الداتابيز التانية اللي هي الباك اب داتابيز او السبير داتابيز دي، هل انا عايزه تبقى في نفس المكان ولا انا عايزه تبقى في مكان تاني؟ اي دبليو اس يا جماعه عندها حاجه اسمها ريجونز، تمام. كل ريجون بيكون جواها اكتر من افيلابيلتي زون. ان شاء الله يوم الاربعاء هشرح لكم الحته دي بالتفصيل الناس اللي مش عارفاها. المهم ان الافيلابيلتي زونز دي بتكون موجوده في نفس الريجون بس ما بتكونش جنب بعضها قوي. فلو حصل ان الداتابيز وقعت في ار دي اس اوتوماتيك، تمام، بتبدا هي تشغل اي دبليو اس تشغل لك داتابيز في مكان تاني. وده برضو ممكن يرد على سؤال الدكتوره اسماء، هي اي دبليو اس بعد ما الداتابيز بتشتغل بتعمل لي ايه؟ اي دبليو اس يا جماعه بتشغل اتنين داتابيزز في مكانين مختلفين. ايه بقى المكانين المختلفين دول؟ هنقولهم بالتفصيل ان شاء الله يوم الاربعاء، تمام. لكن بتشغل اتنين داتابيز انستنس في مكانين مختلفين. لو واحده من الداتابيزز دي وقعت، اي دبليو اس اوتوماتيك بتشغل التانية على طول، وبتكون فيها اخر داتا بالنسبه لك، وبتكون موجوده كل حاجه. ده بنسميها ريزيلينس. خلاص، الرشاقه في الابلكيشن بتاعتك ان حتى لو في داتابيز وقعت، انا برضو ستيل عندي داتابيز تانية تقدر تكمل شغل ومحدش يحس ان في اي مشكله ايه حصلت. يبقى دي حاجه لازم احطها في اعتباري. السلايد دي فايدتها ايه؟ ان هو بيقول لك ده كله لازم تحطه في حساباتك وانت بتختار داتابيز. فبعد كده هيوريك بقى في السلايدز اللي بعد كده ان اي دبليو اس فعلا بتفيد كل الكلام ده. طيب ده من ناحيه الريزيلينس. الخطوه الحاجه اللي بعدها البرفورمانس. هو ازاي اي دبليو اس ممكن تحسن البرفورمانس بتاعت الداتابيز؟ تمام. اي دبليو اس مثلا ممكن ان هي بتزود لك الاستورج بتاعت الداتابيز اوتوماتيك. انا ممكن اغير الانستنس تايب اللي بتشتغل عليها الداتابيز بتاعتي. ممكن استخدم حاجات تانية تحسن لي البرفورمانس زي الالاستيك كاش، ان انا بدل ما كل حاجه تروح تكويري من الداتابيز، انا ممكن اخليها تكويري من فين؟ تكويري من الكاش على طول. يبقى انا كده بحسن البرفورمانس بتاعت الداتابيز. في كمان حاجه اسمها ريد ريبليكا في الداتابيز عندنا في اي دبليو اس، ان انا اقدر اعمل داتابيز تانية صغيره ريد اونلي بس، اقدر اقرا منها، فده ممكن برضو يحسن لي البرفورمانس بتاعت الداتابيز بتاعتي. طب الاوبريشن بتاعتي، عندي حاجه زي الار دي اس بروكسي اللي احنا اتفقنا عليها. ده بقى الاوبريشن اللي هو كل يوم بقى الشغل بتاع كل يوم ده هنعمل فيه ايه؟ فاي دبليو اس عندها حلول، عندها سيرفيس زي الار دي اس بروكسي، ده بتخلي الابلكيشنز الكتير اللي بتكلم الداتابيس بتاعتك ما تقعش وما توقعش الداتابيس بتاعتك. كمان اي دبليو اس هترن لك اخر باك ابس، او سوري، هترن اخر باتشز للداتابيس وللاوبريتنج سيستم اللي بتشتغل عليه الداتابيس. فلو حصل اي سكيورتي جاب على الاوبريتنج سيستم واحنا عايزين نرن باتشز، اي دبليو اس هتعمل لك الكلام دوت لايه؟ لوحدها. اي دبليو اس هتوفر لك سكيورتي للداتابيس بتاعتك. افرض انت عايز تنكريبت الداتا بتاعتك، الداتا بتاعتك موجوده جوه الداتابيس، عايزين نعمل لها انكريبشن، فده بيحسن السكيورتي. طيب انا عايز يوزرز معينين هم اللي يقدروا يعملوا اكسس للداتابيس، تمام. طب ما انا عندي سيرفيس في اي دبليو اس اسمها ايام، عايز يوزرز معينه في ايام هم اللي يقدروا يعملوا الاكسس بتاعه الداتابيس، طبعا with some limitations في الحته دي بالذات. تمام. يبقى كل دوت عايز انكريبت الداتا، عايز احط الداتابيس بتاعتي ايفن حتى في برايفت زون محدش يقدر ياكسسها غير الابلكيشنز بتاعتي. كل ده هتقدر توفره لك اي دبليو اس. يبقى انا النهارده لما باجي اختار داتابيز لازم احط كل البرسبكتيفز او كل المناظير دي في حساباتي. تمام. اي دبليو اس بقى بتوفر لك كل دوت. كل ده ما تحطوش انت في دماغك، احنا هنعمل لك كل ده. ركز انت بقى على ايه؟ على الحته بتاعت البيزنس اوبجكتيف بتاعتك انت، ركز على البيزنس بتاعك انت بس. اتمنى كده تكون واضحه يا دكتور ساره. هايل. اوكي، ثانك يو ايناس، ثانك يو. You can
Thank
continue.
you. Thank you. So just as a reminder, as we are finishing up the theoretical part, this is a map reminder of the purpose-built databases that AWS has for the different workloads. Today we focused on relational, but tomorrow we will look at the other types. And when we are considering databases, it's also important to mention how we possibly would need to migrate. So let's briefly talk about some options that we have. AWS offers a variety of migration tools, programs, and support options. We understand that these tools and experts would help you with planning and building the right path when you consider such things such as a migration to AWS. The first and simplest consideration for moving to a fully managed cloud database, such as the ones that we've been seeing, would be to keep the same database engine with minimal to near zero downtime. So this would be an option if you want to keep the same database. The recommended approach when you consider something like this would be our free self-service tools, such as Database Migration Service, also called DMS, where you can make homogeneous migrations. So homogeneous in the sense that it would be the same type of database to the same type, so without making changes for your legacy database service, now to managed data service. For example, Oracle to Oracle in RDS. This would be such a type of migration. We also have Fleet Advisor, which is towards customers that are looking to move a fleet of databases to the cloud. So it's a tool that will do an inventory and analyze your data. So it can create a customized migration recommendation for you. We also offer specialized database programs to offer migrations and support and expert advice. So we could consider the Amazon Database Migration Accelerator. And finally, We have teams of experienced professionals and a network of AWS partners, which have deep expertise in such migrations and database applications. And they even specialize in helping customers navigate through this licensing aspect sometimes. So in short, it is whatever you prefer. You can do it yourself, you can do it with partners, or have AWS do it for you. The bottom line of this is that we can help you migrating and modernizing your database applications, and we are happy to help you on this. We have over 200,000 databases migrated to AWS using the most recent public stats. And to finish up, when we consider platforms such as AWS or other cloud providers, we are looking for a platform that does it all. So we are looking for, in today's time, a business and intelligent machine learning, such as forecasts, translation, speech tasks, recommendation, visualization. We're looking for solutions for analytics, for data warehousing, for interactive analysis. We're looking for solutions for different types of databases because we have moved past only relational database world. And we're looking also for solutions such as data lakes, where we store our data lakes and how we move our data. And this is where AWS offer comes up. So we have a very comprehensive and open portfolio, and with offers for these type of use cases that you are seeing on the screen, we would have an offer for them. Our call to action would be to, if you need to see more information, there is this website where you can see everything on AWS's databases, and also how to contact us. You can reach out to any of us with questions. And if you want to learn more on databases, there is the AWS training and certification. We have more than 25 free digital trainings. We also have a classroom offering. And if you want to validate your experience on databases, we have an exam, which is the Certified Database Specialty exam, which if you want to test it out, there you can search for it. On my side, and Alejandro's, I wanted to thank you. I'm going to share with you a survey. I have prepared a quick demo if there's time, but I would like to know how people are feeling at the moment about this before I go into anything else.
Excuse me, Nes, we have a question in the chat, please.
Of course, I cannot see the chat, but if I maybe stop sharing, I will be
please.
able to see it. If you could clarify, high affinity solution awareness might hamper adoption. Could you clarify? Sorry.
Okay. Please, Dr. Sami, would you please clarify your question, please? Okay. So, Inesi is raising hands, so I'm
Of
going
course,
to
of course.
unmute.
Please,
Okay.
please.
Yes.
Good evening. Thank you so much.
Hello.
Hello, hi. In the slide that immediately after the uses of or what is required from a database, there was a slide that split into half. The upper half was high affinity and lower affinity. I don't know if you can, it's like 3 slides ago. So if you bring it, you'll find it in the second paragraph. It says that with high affinity solutions, maybe the awareness might hamper the adoption of the high affinity. It's when AWS would use a database solution, and then they look in the market whether this solution had been used before or not.
Give me just a second. I'm trying to bring back the slides so you can tell me where it is.
Of course, take your time.
Okay.
I cannot see the slides, by the way.
Yeah, I know. Okay, slide 2, sure. And now I'm gonna look for the slides.
Yeah, it's at the bottom now, on your left, the extreme left. It's the first one on the left-hand side.
Yes.
Yeah.
On the bottom now, sorry.
The slide at the far left, please.
The slide, this one, solution affinity.
Yeah.
Okay, and at the bottom, where it says solution is broadly adopted in a market for a particular use case and is good enough fit for that use case. Solution is not a good fit, extensively used. The solution can be made to work. But awareness may hamper. Solution is very good fit, but awareness may hamper adoption. I'm sorry, I cannot explain how it says there, sorry. But I can certainly look it up and get back to you. I did not notice this sentence, so I'm sorry, I cannot explain it. I don't know if anyone else in the meeting might know, but I will look it up. So if you are still hearing me?
Yeah. Is there any questions, please? Any other questions, please? Okay, Dr. Ahmed, Ines is going to return back for us for this sentence, and I can share, or Muhammad Salah can share the answer with you.
Thank
Okay,
you.
do we have any other questions, please? Can we go for the demo? Okay, how much time for the demo, please, Ines?
I can show something quickly if you would like. And we
have
finish
only
at
15 minutes left. We have only
exactly.
15
So the
minutes left.
demo was 15 minutes. So I think if everyone is fine.
Yeah. Okay, so any questions before going for the demo, please? Okay, so you can go for the demo, Ines, please.
Okay. Hopefully you are seeing my screen. So you're seeing the AWS console.
Yes, we can see it, yes.
Thank you. So I wanted to show you when you are launching databases, a bit of a few options that you might have. So let's consider our RDS relational database service. And as you can see, I have a couple of databases already launched. And what I want you to see today is how you manage these databases, what you can see, and also that it is not so hard to connect to as we might do with another type of databases. So let's go into create database to see a few options. When I create a database, you can see here that I can select the different type of engines that we've been talking to about today. So Aurora with different compatibility options. And also, for example, in Aurora, I would be able to select if I wanted to be serverless instance configuration or not, if I wanted to be memory optimized or a burstable type of instance, and also see the capacity range that I wanted to go between. Also, you can see here on availability and durability, if I wanted to be a multi-AZ deployment. So if I wanted to create an Aurora replica in a different AZ or not. And also for connectivity, there are here some options to be able to connect easily to an EC2. And here, why would it be interesting maybe to connect to an EC2? Being an EC2, our virtual server. So if we, here we are seeing the EC2, so our virtual servers running. Why would it be interesting? Because if we want to launch our database without being able to be connected from the internet for security reasons, it could be interesting to launch an EC2 instance, which we could call it something like a bastion host, and it will help us jump and connect privately to our RDS instance without having it open through the internet. So we would be connecting to our server, let's call it our server, but our database, which would be running on RDS, would not be able to be connected directly. So we would be increasing security. So thus here we have this connectivity option. We can also configure the subnet groups, and these would be more focused on the security, which would act like a firewall. We can also trigger our performance insights of our databases. And finally, we could create a database. When we choose something like Postgres, we could choose between familiar engine versions that you might be running. There's also templates to use this and try it out on free tier if you desire, and also different deployment options such as having a single database, a multi-AZ database, or a multi-AZ cluster. The normal configurations that you might be considering a name for the DB cluster, your username, and the password that you would like to connect to. Let's look into some databases that I have here already created. As you can see, I'm just by looking at this management panel, I'm able to check things such as the CPU, and also let's just wait for it. So we can see the CPU usage, our crowding balance, our burst, how many database connections we have open, also our utilization, database load, and all of this is done without having to configure anything. So it is being monitored by default. And still on here on Amazon RDS, we would be able to see our snapshots, which I will show you how to, for example, configure a snapshot, and things such as exports to Amazon S3, manage subnet groups, which would be where would be launching our databases. For example, a subnet group would say, okay, in region US East, I want to launch in all of these availability zones, and I could select where I want to launch them. So let's look again, for example, to one of our databases, for example, RDS Postgres. Let's see some actions that we could take. We could, for example, create a read replica. We could select blue-green deployment if we want to minimize our downtime during upgrades. So, for example, we could have testing different changes that we made. And as you see here, for example, you could select to take a snapshot or restore to a specific point in time, which is something that we would also have configured. At last, just to finish up the session, I wanted to show you how you can connect to, for example, this database. So I will show you, I have configured an EC2 instance, which would be my jump bastion host. And I have a database open to this EC2 instance. So I will now go into my terminal. And I'm sorry that it is a white big screen, but hopefully you can understand everything. So first I would connect to my EC2 instance, so my bastion host. And as you can see, the connection was approved. Then from my bastion host, because I have opened the ports and the protocol to RDS from my EC2. So my EC2 can talk to my RDS, even though my database instance is not accessible through the internet. But because I'm inside the server, I'm able to connect to it. So now I'm going to try to connect to my database. And as you can see now, I'm already inside the database Postgres. So I could do tasks normally. I just want to give you some examples. For example, I could create a table. I could do inserts normally. And it would work just like a normal database. So we are expecting now, after creating a database and inserting something into it, that we would be able to see it. Maybe I did not do it correctly.
Oh.
Yeah, let me see.
Yeah, some data. Insert some data, yes.
Yes, so so insert as more expressions than target columns, because I would need something else here. So I'm going to create a smaller table, if you do not mind, as it.
Yeah, no problem.
If you.
Would you please make the screen larger, please, Ines?
Of course, I will do both. Let me see if I can make it. Okay. Okay. Perhaps I need to commit after insert. I think what I did incorrectly was that, as you can see, links has a lot of fields, but two are not null. I get what you said. Okay, let me see if I can do it quickly. But anyway.
No, there is a syntax error in the insert statement. Just a second, I will try to send you.
Thank you all. It's just I prepared the statements and doing it here now live. It's not working as I expected, but.
Just enter, please. Just enter.
Just enter?
No, enter for insert statement, yes. The problem, yes. For the insert statement.
Okay.
Yes, just try it right now.
Okay,
Try to
so now it worked. I don't know why I was obsessing with it, but thank you. Okay.
Yes.
Okay.
Please remove the spaces.
Okay. The copy and paste is not being a good friend of mine, but let's go. Well, I apologize.
No, the insert statement. Okay, let me. Okay, just give me 1 second, please.
Thank you.
You are welcome.
The issue with live demos. I'm sorry, everyone.
No problem. That always happens. Links, the table name is links. URL. Test URL. What else do we need? Please try this insert statement, please.
So
Just paste it in the chat.
yes, the problem is that I cannot see the chat, but I'll go into. Thank you all.
Okay, yes.
The question on the chat, if there's this tool that we could use instead of comments. So normally when we would be working with the database, this is just a test that I wanted to show you, but we wouldn't be working like this. It was just really for the demo. Depending on the database, you would have a query editor that you could use or not. But well, I'm not being able to solve this right now. I hope you all got the idea that we could interact with our database. And if I could show you the schema, you would see some tables created, but now my Postgres level is not being the best that it can be. But I would
What is the table name? What is the table name?
links.
Links?
Yes.
URL and name?
Yes. So the table creation works fine. When I try to insert something, it wasn't working because of something that I pasted incorrectly.
Just second, just second.
So
That's an
we
insert
are
statement.
all buggers here in the
Would
chat.
you please tell me the column name, the first column name, please?
So
URL, I think.
yes, but then I'm missing the data, I believe. So inserting two links, URL, then I would need to insert a URL and a name, but I'm not sure. Because I'm missing the data, I think. But yes, regarding labs for the databases, I can also reach out with workshop links. Thank you. It's exactly this. It's the value part. Thank you.
Yeah.
But we just need to change something for the. Give me 1 second. Just taking care of it. Okay, finally inserted. Thank you. So when I was preparing the demo, I scratched the value insertion and now I could not see it. As you can see, it has been inserted. And as we do our select, it would work. As you can see here, our links has been inserted. I hope you all enjoy debugging sessions. When it comes to
this is great. This is much more better.
No, much better.
This is much more better. Yeah, because they know now how to make the insert statement. So this is much more better.
we all got reminded how to do SQL commands. But as we are reaching the hour, there are workshops, free workshops to explore things like this, which I can reach out to Ahmed and send it to you. So I can follow up tomorrow, I don't know, on a question that was asked here today, but it can also be followed up on email as you prefer. And that is it. I wanted to thank Alejandro and Ahmed for helping co-hosting and helping us with the translations when needed, and all of you for attending. And we will see each other tomorrow, hopefully, if you attend the unstructured data part of our sessions. And I hope this was useful. Again, sorry for the live demo part, but hopefully you all learned something or saw something different. This is our survey for today, as I pasted again in the chat. And thank you all for coming. I don't know, Ahmed or Alejandro, if you want to say anything or anyone has any questions.
No. One thing I want to tell them, please, in the part of the demo, what is the Bastion host? Okay, the Bastion host, because the database was in a private subnet, so the database didn't have any public IP, so I cannot access the database directly. That's why Ines used a Bastion host. This is this instance is in a public subnet that has a public IP, so Ines can make SSH on this instance, and from this instance can make access to the database in the private instance. That's why Ines used a bastion host instance. That's it. That's why I want to clarify for all the team. Okay. Any questions, please? Any questions? Thank you.
Thank you all.
Thank you. Thank you for all of you. Thank you. Thank you, Ines. Thank you, Alejandro. Alejandro. I
Alejandro?
hope I can pronounce it right.
It's fine. You can call me Alex otherwise.
Alex. Alex, much more easier. Yes. Okay.
Okay.
Thank you, Alex. Thank you, Ines. Thank you, all of you. Yes. Yes, G is silent.
Well,
Okay.
thank you all, and
Yeah, thank you.
tomorrow we'll have a session on unstructured databases then.
Perfect. See you tomorrow. Have a good day.
Bye.
Thank you. Thank you all. Bye-bye. Thank you.
Bye.
شكرا لكم يا جماعة كلكم، واشوفكم بكرة على خير بإذن الله، والسلام عليكم.